नमस्कार माझ्या मराठी मित्रांनो, पुन्हा एकदा तुमचं मराठी AIML या चॅनल वरती स्वागत आहे. आज आपण एंड टू एंड मशीन लर्निंग प्रोजेक्टचा सेकंड पार्ट बघणार आहोत आणि आज आपण बघणार आहोत की डेटा कसा मिळवायचा आणि वन्स वी गेट द डेटा what are the things needs to be taken care initially. We already have seen the part where I have explained what is a problem statement. Once we get the problem statement from the manager or from the stakeholder or from the client, then what are the right questions to ask? And once you ask this question, how this question help you to develop or to build the machine learning project. Based upon that, we also seen a two matrices to evaluate your machine learning model. One is the RMSE, root mean square error, and second is the MEE, that is mean absolute error. Okay, and what is the difference between them? How statistically or mathematically they are different from each other, and in which cases RMSE must be used and in which cases MEE must be used, I have already explained in the previous video. So if you have skipped or if you haven't watched that video, please go and watch it and then come back to this lecture. Okay, so without further ado, let's start today's lecture about get the data. Before that, I really want to thanks to everyone. Recently I have got 1000 views to my channel and more peoples are watching my video and they like my explanations. Okay, if you still have any doubts, please post in the comment. I'll definitely answer as quickly as possible. But really, thank you guys. You are helping me a lot and you are boosting me to do more such a video for the better understanding of machine learning things. So let's start now. So second is the second, we already understand the big picture of our problem statement. Today we are going to focus on get the data, and don't worry, today we are doing practical. I request everyone, open your Google Colab, okay, and do it along with me. Okay, next. So as I mentioned, we are going to use a Google Colab. So why we are using Google Colab? Just to save our time. I do not want you guys to waste your time to setting up the environment, okay, rather than just work on the actual problem, okay, and then whenever we will have the time, I'll definitely explain how to set up the environment. But to just your time, just to save our time, I'm using the Google Colab. Then I request, please code along, work along with me, means code along with me, so it will give the more better understanding. Okay, next, now the what kind of data we are going to use. So typically when we are doing the real world case problem, okay, the company has saved their data in the relational database. I mean to say relational database I mean SQL, MySQL, then MongoDB, so I mean to say these kind of where we have the table, okay, kind of databases are available. Okay, their database, they save the data, and then from that database we are accessing the data to do our machine learning works. Okay, so but when we are doing our practical works, we don't have such a database available setup, so we will use some kind of CSV file or Excel file for our program. But understand, in reality this data is stored into the relational database. Somewhere it is also available in common data store. So for example, if you are working with the cloud storage, then there is a Azure blob storage, AWS S3 bucket are available. So other data stores are also available that we can also use to accessing the data. But in this project, as I said, we will use a GitHub as our data source. Okay, and from the GitHub we will access the data and download in our project, and then we will work on that things. So today our agenda is get the data from the GitHub. Okay, next. Okay, so before moving to that stuff, okay, let me share my Google Colab file and then I will explain you how to get the data. Okay, so as I mentioned, I'm not just going to execute the code line by line, but I will also explain the standard way of writing the code, how you can write the code in very efficient way in your real projects as well. That will increase the efficiency of the projects. Okay, so basically I have the data in my GitHub. I will share the link in this video. You can access that. So I'll require few libraries before start my work. So let me use those libraries. So import OS. OS is the operating system library in Python. It will help you to create some directory, access the file from the directory for that. Then another library I require is called as the tar file. So tar file basically it helps to unzip the tar, okay, and get the data from that tar file. Then there is another library from the 6.moose import URL lib. Okay, sorry, it's a URL lib. So URL lib is basically a library to retrieve the data to access the any web page. Okay, so to access the web page from, because we are accessing the GitHub link, okay, and GitHub is on the internet. To access that internet link, we will use URL lib. Okay, so let me execute these things. Okay, I think my Google Colab is connecting, so let's wait for some time. I hope same for you. Yeah, it's initializing, and in very soon, yeah, it's connected, and then it's okay. It's giving something, some issue with me. So what it is that cannot import the URL lib from the 6.moose. Okay, so is it correct? Okay, I think something I made a mistake here. Okay, so URL, okay, it's a URL, sorry, not IL, URL lib. Okay, so like this is the way, that's why I'm saying do it with me. Okay, because this kind of problem really teach us what errors are there and how to solve that errors. Okay, so that's why do it along with me. So I have written a wrong spelling, that's why it is not importing. So correct one is a URL lib lib. Okay, now I imported all the libraries. Now let's move to the link. Okay, so I have capture. So first let's mention the download root. So download root is specifically variable which contains my link where my data is stored. So let me copy that link and paste it here. Okay, so this is the link where I have my data. Okay, I will definitely share this, okay, so that you can also access. So this is my link. Okay, then I need I need to create a directory where my this data is stored. Okay, where this my data is stored. So like os.path.join, it's a data set is the directory, and below the data set there is a housing is the directory. Okay, so how this is my path, this is my link, and this is my path where my data is stored in the GitHub. So os.path, spelling is wrong. So os.path.join, and what is the, so my complete URL link is that housing underscore URL is this my download route plus, so this is my actual GitHub link. Okay, in that GitHub link I have the directory called dataset, in that housing, and below the housing directory I have the my data set is stored. So I mentioned housing path, this is my link, and now to make the URL, so I add this download route plus housing path. Okay, otherwise I can also mention like this. Okay, so I did this to create the, let me mention here, to create the directory structure in my OS. Okay, and my housing URL will be the like this, the download route dataset housing slash housing dot tgz. Okay, so actually when you access my GitHub, okay, in my GitHub it is stored into the dataset housing. So similar structure I created here only to store. I'll show you how it is created, but this is a complete URL. So this is the link. In my master I have the dataset directory, below that I have the housing directory, and below that my housing tar file is stored. So okay, let me execute this. Let's see if I get any error. No, that's great. Okay guys, I'm showing this. I can do it very easily to download the data from the link, GitHub link, and then I can upload the data manually, and then just like here upload, and then I can directly access. But I just wanted to give the how you can in real world how the things is working actually practically. This is not happening in practical stuff world. Okay, you have to write a function for each and every stuff. Okay, so we will follow the same practice. Okay, that's why I'm doing this lengthy process. Okay, so now I need to write the function to fetch the data from GitHub. Okay, so I'll write a function called fetch housing. Sorry if I'm writing any spelling wrong, but we will correct it. Okay, don't worry. So this is my function, and in function I have to give the URL. Okay, so I'll mention a variable called housing variable, housing URL, sorry, housing URL. Okay, you can mention the default value as well. This is the specialty in the Python. We will lecture see in Python series, but still while I'm doing this practical, I will explain by in a minute or two. Okay, so that you can also get the intuition behind that what I'm doing in Python. So this is the good things in Python, that you can give the default value. If user is not passing any value to the function, function can use the default one as well. Okay, so housing URL by default, if it is not, then by default it must use this URL. So I copy here, I paste it. Then what things I require a path, right? So user must say give the path where I have to download that data, right? So for that I use housing path, and the default value is this. Okay, now I am inside this function. Now I have to create the directory. So I use if not os.path is directory. What is that? Housing path, right? So I'll use this housing path. Okay, then os dot make directory of housing path. Where is that? So what this line actually means, it means that if housing path directory is not created or is not present, then create it. Okay, so it will not execute this function again and again. If it is not present, if this directory is not present, that is dataset below housing, then create it. Otherwise don't create. This is what the meaning of these two lines. Right now I have to mention the, okay, now I created the directory. Okay, that is housing with parent directory. Below that, sorry, dataset is parent directory, housing is the another directory. Now I have to give the I have to create the tar file path. Like what name I have to give my tar file, because that tar file coming from my URL. Now what tar file name I have to give here? So I'll mention target, that is tar file path, tgz path, os dot again path dot join. Okay, so housing path is my directory structure, and below that I have to want to create the tgz file of name called housing. Okay, I keep the same file just to avoid any confusion. You can give any other things. So I'll create this directory structure. Okay, so in my housing path I'm creating housing tar file. Okay, now this is done. What next is that I have to access that URL. Okay, and to access that URL I have already used one library called as from the 6.moz. So I'll use this URL lib, and there is a one method called request and another method URL retrieve. URL is it URL retrieve. Okay, it's fine. Okay, and I have to give the path. What is this path? This path is nothing but the, okay, below that, before that I missed one thing, that, okay, I have to give the path, right? So okay, this is the housing path URL retrieve. I have to give the path, right? So housing URL is one of the path. Yeah, so here is housing URL. I got it. So housing URL, and in housing URL, this is the path. Okay, this is the path. So what is my housing URL? If you look at it, it's a download route till this. So it will fetch the data from here, okay, from this stuff to, and save it to the TGZ path, like here. Okay, so you understand, this is my source URL. Okay, it will download from here, and second variable means where to save. This is called as a second variable. Okay, now I save the file housing, but my second important point is to extract the data from that, right? So I will use another variable called as housing TGZ is equal to, and to open that tar file, I have the function, I have the library called as tar file dot open, and where I have saved into the TGZ path, right? So I will use TGZ path. Okay, because that data is stored in TGZ path, so I have to open that tar file. So once data is saved there, I will open that tar file, and after open, I have to extract the data, right? So I use housing TGZ dot extract all. Yeah, it's coming. Extract all, and what is the path? Where to save that path? From the housing path. Okay, so where is housing path? Yeah, here this. Just to save time, I'm copy pasting. Okay, and then close this stuff because that is the requirement. Close the stuff. Let's execute. Okay, it's, I think, not giving any error. Now let's call this function. Okay, as I mentioned, you can give your value of housing URL or housing path. So what is the benefit of this? This is a standard. You can use this function as many times as you want with your variable. But as I mentioned, I haven't given any value, so it uses the default one. So let's execute and let's see what things we are getting. Okay, so it's saying that my module OS has no attribute called make dir. Okay, it must be dirs. Okay, first execute this, make directory. Okay, it must be yes. Okay, now what is giving 6 moves URL request? I think I did something error here. URL retrieve. Okay, spelling, I think that is a spelling okay, it's a URL, it is coming as a UTL. So this is happening. You must, now again it is showing, okay, my lot of spelling mistake. OS dot path, which line, extract all. Okay, housing path. Yeah, it must be, it's a requirement of that function. You must mention path. Yeah, it's done. It's, guys, done. Okay, now it's important. So this function is, okay, see, the directory structure is created here. Data set, housing, and below that we first download this housing TGZ, and then using this function extract all, we extracted that file. Okay, so now we got the data. So we assume that GitHub is our data store, and from that data store, using the function called as fetch housing data, we extract the TGZ file into the housing folder in our OS directory structure. Our OS directory structure also we have created, and we save the file there. Okay, now our job is very easy. Now we have to read those CSV file. So to load the CSV file, we use pandas. I think I already explained in my first lecture of machine learning, where I have mentioned the train and run ML model. That was the first practical I have did, and that time I have explained the pandas function in very short. Okay, so you can refer that one, okay, for the better understanding. So import pandas as a PD. Okay, now for loading the data, and read the data, we will also create another function. So we mentioned that def load housing data. Okay, and to load the data, we must give the path. Okay, so first path as a housing path, and the default value of housing path is this. Okay, housing path, and we mention a CSV path. So os dot path dot join. Okay, CSV path. So it is housing path, it go till this. Okay, so my housing path, and in my housing path I'll come here, and then I have to give this name of the file, call as a housing dot CSV. Okay, and then return a PD. Yeah, PD read CSV. Okay, read CSV, that name house sorry, CSV path. Okay, let's execute. No, let's mention a name housing is equal to, because it will return that CSV file, and I'll call out this function. Okay, it's executed. Let's read the file. Yeah, so now data is extracted. Okay, so let me revise in 1 minute what we have did here. So we write the function, right? In that function we have given what file name is there that we want to extract. So we already know the housing path, right? Housing path has my data path. Okay, and I'm giving the housing because that file I want to. So I join that, my housing path and housing CSV I have joined, and I have given the complete path which is stored in a CSV path, and it will return. Then I call out that function. Okay, that function return a data frame that I have stored in housing, and then I using housing head. So head is what? It's a pandas data frame method which will give the first 5 rows result. First 5 rows result. Okay, see here 0 1 2 3 4 5, 0 1 2 3 4 5. So you can see it is having the longitude, latitude, housing median. So now you can see what data it has. It contains longitude, that is, now each 0 1 2 3 4, each row means one district. If you know what our problem statement, if you haven't watched, I again request watch the first one because it is very much interlinked here. So 0, this is my first district information. This is the second district information. This is the, let me take the pencil. Yeah, this is my second, this is my third district information, this is fourth, and this is a fifth, and it goes on. It goes on. Okay, here we using here, that's why we only see the first 5 records. Okay, so it contains the longitude, it contains the latitude, so it gives the location stuff. Then housing median age, it means the age of that property. Then total number of rooms contained, then total bedrooms, population, household, median income, and then it's me, right? Yeah, median, clear, median income, median house value, and open proximity. Also, it contains this value. Okay, it contains this value. Okay, so we have this value. Let's go deeper into that and check the info. Oh, sorry, so pandas data frame has this variable method called as info. So what does it actually gives? It gives the number of non-value present here. Now these are my features, or you can say these are my attributes. Okay, so how many features I have? I have total 9 attributes. Okay, specifically these are, and it says my longitude contains a non-null value 2060640, means 20,640. 20,640, 20,640. So if I look at all the data, it contains 20,640 value, means these many districts I have. But if you look at these total rooms, sorry, not total rooms, total bedrooms, my total bedroom contains only 20,433 value. So what is the significance of this? It means that it has some null value. And how much null value it has? Let's take the calculator. Yeah, here 2640 minus 2433. So 207, almost 207 missing values in the. Okay, so let me write down here as well. 207, not 307, 207 missing value in a total bedroom feature. Total bedrooms feature. So this is the benefit when you using the out of 2640 districts. Okay, so it means 207 missing value. Missing value means what? 207 missing value in total bedrooms of, so I mean to say 207 districts, not missing, 207 districts. Okay, so 207 has a districts have the has missing value of total bedrooms. Okay, this is the significance of that stuff. So 207 doesn't give the any information or the null values of the total bedrooms. Now how to treat such a null values, we will see it later. We will not going to touch now, but here our agenda is just to understand the stuffs. Second thing, it is also giving the data type. So my all the features has the data type called as a float 64. Okay, but my ocean proximity contains the data type called as a object. Okay, so this is something, we can see it's a object data type. So this is the things, we don't know, but yeah, in Python there is a call as a object data type. It can has a object data types. Okay, so what that proximity contains, let's see. So if you look at the proximity contains a nearby. It looks like something a categorical feature, right? Categorical feature. So let's look at what is that. So for that I use housing. That is my data frame. I want to extract the feature of ocean proximity. Ocean proximity. Let mention head. Let access the value of 10 value. Okay, so it contains nearby, right? Let's access the unique value. Yeah, so using the unique, I can say it contains nearby, 1H ocean, inland, near ocean, Iceland. Okay, so it mentioned data types object, but for us this is what something, it contains the categorical information. Okay, let's see how much value for each categorical variable has. So I want to understand the count for nearby, for count for the inland, count for the near ocean, count for the Iceland. So how can I get it? Housing. Okay, let me copy paste this stuff, and then I use value counts. Okay, so I understand that 1H ocean contains 9,136, inland contains 6,551, then 2658 for the near ocean, 2290 for near, and Iceland contains very less value, that is the 5. Okay, so this kind of information we understand. So this, okay, so as of now we understand this is the stuff. Okay, so though it is mentioned as a data type object, but it contains some categorical information. Now we got the data, we understand it contains some missing value, we understand ocean proximity, though it is a type, is an object, but it contains a categorical information. Now let's look into the some statistical information. So for that we use housing describe method. So this is again pandas one another method called as a describe. It's a describe. Yeah, here it is. So sometimes this is very important stuff to analyze the data. There are two ways. One person can go with the this way, and another is also something called as a visualization way, but this is also one of the way. Okay, so what it contains the count. Count means total number that we also get from this info. Okay, so it contains the count, and here we can also see the same value, only total bedrooms contains 2433. Okay, then it contains mean, contains standard, mean, 25 percentile, 50 percentile, 75 percentile, and the max. Okay, sometime it is also called as a 5-point summary. We will see in a minute what is 5-point summary, but 5-point summary is nothing but the this is 1 2 3. So minimum, maximum, 25, 50%, 75%, and median value. Median value is nothing but the middle value of that data. Now, why we are looking this statistical information? So let's understand. So if you look into this thing, so mean is nothing but the average. Okay, let me bring my slide here. Okay, I prepare something for you to understand this stuff in here. So mean, what is mean, guys? I think everyone knows mean is nothing but the average. Okay, but just to revise in a minute, suppose if I want to calculate, these are my data points 19, 6, 17, and 6. Okay, these are my data points. If I want to calculate the mean, or you can say average, how can I calculate? I will add those numbers 19, 6, 17, 6, and then divide those number, divide this addition with the total number. So how many numbers I have? 1, 2, 3, 4. So 4. So addition is 48 and the count is 4. I'll get this average. So mean is nothing but the average, where formula is very simple. Sum the numbers available and the total number of numbers we are taking for taken the addition. So this is called as a mean. Okay, so this is what we are getting here. Okay, so mean is, so when I say longitude, there I have 2640. This is my count, and then I added all the longitude values and divide this by this, so I get this. So something it is coming as a negative. Then this mean is a 35. For housing median age is 28. Then total bedroom mean is this, total bedroom this, population this, household is this, and then this is 20. Now just to give the intuition, if you understand, this is a median housing value. Okay, and value coming as a $26,855. This is in the dollar. So it means that on an average in that district, okay, in that the area for which we are calculating this stuff, on an average the housing price is 22,06,855 on an average. Okay, we usually say that, right? On an average the housing price in the state of Maharashtra is 2 lakh per square, per 1000 square feet. So similar way you can compare here. So on an average the housing price is 2,06,855. This is what we get the understanding, right, of this. Next up is the standard deviation. Now what is standard deviation? Let's understand from the presentation. So if you look at the standard deviation is nothing but it gives the measure the dispersion of data. So my data, how much my data is dispersed, how much data is is spread. If I wanted to know the mathematical way to get that information, then we use the standard deviation. Now how to calculate the standard deviation? It is very simple, guys. You just need to subtract the each and every point from the mean of that data. Now how to calculate mean, I already explained some time back, right? So you have to subtract the each point from the mean, then taking the square of that and do the addition of all the points and divide that by n. What is n? N is nothing but the population size or the count, the number of data is available in that, and then take the square root. This is called as a standard deviation. Now, just to explain this thing in detail, I have given the reference link of this a very good website called as Math is Fun. Let's try to understand using that. Okay, so let me just clear this drawing. Okay, and use this. Okay. Okay. Let me we use this. So this is one of the very good website. It will explain the standard deviation, and I'm also referring this to explain in detail. So standard deviation is nothing but it is a measure how my data is spread. To understand this, I using the standard deviation. Okay, and the symbol is this is a geek symbol. How to calculate the standard deviation? Standard deviation is nothing but the square root of the variance. So what is again variance? The stuff we have seen, xi minus mean, then take the squaring, and then n, and do the summation. This is nothing but the variance. Okay, and when we are taking the square root of this stuff, it is called as a standard deviation. I hope you understand. Okay, this part is called as variance. When you take the square root, it is called as standard deviation. Okay, for example, let's scroll down here. They have explained with the very good example, dog cat. Okay, so this is a dog, and they have given the height of each dog. The rate, the rate stuff you can see here. This is the height. So for this dog, height is something 180. For this dog, it's something 410. For this dog, it's 600. So they have given the height of all the dogs, right? Now find out the mean, variance, and standard deviation. Now how to first we need to calculate the mean, right? So how to calculate the mean? It is very simple, guys. Again, you just need to do the addition of all the heights. How many dogs are there? 1, 2, 3, 4, 5. Divide those by 5, do the addition, and we got the 394 as the average. Okay, because that is the requirement when you calculate the standard deviation, right? This is the mu. Now next, once we got the mean, we will draw the line in our graph. Okay, so this is the mean, 394. Right now what I'll do, as per the formula of standard deviation, we just need to I just need to do xi minus mu. So this is a one very important question, guys, how to calculate the standard deviation. So just look it very carefully here. So we first calculate the mean, then we subtracting that each data point from the mean. So look at here. So my mean is 394. Let me just scroll up here. Yeah, so my mean is 394. Okay, what is my dog height for first? 600. So I will minus 600 from 394 is 206. Again, for this dog something, I'll get the subtraction 76. For this dog, it is something. So I'll minus that from 394, I get minus 224. Then obviously it will be minus because it is a less than my average. So whatever subtraction it will come, it is in minus. Then I do the subtraction here, it gets something 36 and then minus 94. So I did this calculation here. Okay, now see here we are getting how my data is vary, how much data is spread from my mean. So this information I'm getting here. Then after that, what is the importance? We have to do the squaring of each things and do the addition. So this is same stuff we have did below. So we are taking squaring of each everything, 206 square this, and then do the addition and divide by 5. Here we get the variance. Now question, this is a variance, right? This is called as a variance. Why we are using standard deviation as variance is also give the spread of the data? Because variance is not that much of it will not give the that kind of differences, because see, it's a 2170. You didn't understand anything from this, right? Because it's a big value. So to get the spread, we are taking the square root of this. Okay, so see, when we are taking square root, it's coming around the 147, which is something nearest to the mm. Now if I want to put this into the graph, here, if I want to put this into the graph, so I understand that from the mean, if my data comes below this 147, okay, falls in the 147 range, so this much of data is this is the 147 is what? It is my standard deviation. Okay, so how much? So So this is the range where my maximum height is there. Okay, anything below this standard deviation I consider as a short height dogs, and anything beyond this I consider as a big height dog. So this is, I think, the importance of guys standard deviation. So it will gives the what is the range, standard range, where the maximum height of the dog falls. Below that 147, very short, and above the max it is called as a up. Now I explain what is standard deviation, but what is the importance of this stuff? Okay, let me go to the PPT. Let me clear the drawing. Let's go into the presentation. Now see, anything comes under the one standard deviation. One means 147, remember. Okay, for one standard deviation, 68% data falls under the my one standard deviation. Then if I calculate two standard deviation from the mean, this is mean, right? So from two standard deviation to the left and two standard deviation right, if I consider this box, then 98% my data falls. And if I consider 3%, third standard deviation, then 99.7% data falls in the third standard deviation. When I say two standard deviation, three standard deviation, it means you multiply your standard deviation value, that is which we got 147 into 1. If it's 2 standard deviation, that is 2 into 147. If it is 3, then 3 into standard deviation. So statistically, if my data is normally distributed, it understand that it proves that if my data is normally distributed, so most of the data it falls into my third standard deviation, which is 99.7%. So anything which is beyond this, we consider mostly that is as a outlier. Okay, outlier kind of data. So these kind of data is called as a, we generally, no, it is not a right way to say, but this is a out of our range. Okay, so this is what I explain about the standard deviation. If you still have any confusion, I'll really say refer this math is fun. I will share in my YouTube stuff. Okay, YouTube link. Okay, let's now move to the standard deviation. So let's jump to the our code. So guys, this is a standard deviation stuff. Okay, so for the longitude, my standard deviation is 2. So from my mean, above the standard deviation 2 and below the standard deviation 2, most of the data falls. Similarly for the other variable. Okay, now not wasting much time, like let's move, it's bit a long video. Then mean is nothing but the minimum value. 25 percentile is nothing but the minimum value in the longitude. 25 percentile is nothing but the, this is very important guys, because when you are calculating the outlier, we are generally use a term called as a Q1 percentile, Q2 percentile, and Q3. Q2 is nothing but the median value, Q1 is nothing but a 25 percentile, and Q3 is nothing but the 75 percentile. So when I say housing median age 18, so what is mean by percentile? Percentile is nothing but the my 25. So let's consider this housing median age variable. So my 25% of districts has a housing median age is less than 18%. I'm again repeating, but there are 25 districts which housing median age is below than 18%. Similarly, there are 50% districts which has median age value, that is age value of the house is below 29%. When I say 75%, there are 75 districts which housing median age is below 37. Okay, so this is what percentile means. Percentile is nothing but it gives the value below which how much data is. So 25%. So below 18, there are 25% data or district contains the age below 18. There are 50% of districts where housing age is below 29. So this is the understanding of this 25, and max is nothing but the maximum value in that features. Okay, now let's move to the another stuff. Now we understand this stuff guys. Now let's try to plot the graph for all the, as I said, there are two ways. One, you go with this describe method, but we can also draw the histogram, okay, to look into the data. So I use matplotlib for this. So matplotlib as PLT, I use housing as a data frame. So housing.hist, then I use bins. Bins is nothing but the how much you know, that the block we must consider. So we consider 50 blocks, and then I'll mention the fixed size equal to 20 comma 15, and then plt dot show. Let's draw this. Okay, spelling mistake. Fixed size. Fixed size is nothing but the figure size, guys. Yeah, so here it is. So we draw the diagram. Okay, 50 means we consider the 50 this, as I mentioned, guys, the width of this is 50. So this many rod we consider 50 value. If you count, we consider 50. This is called as a bins. Okay, now here we draw, guys, all the feature: longitude, latitude, housing median till median value. Now if you look at the graph, not all the graph is exactly normally distributed, but if you look at all the graph, they are normally have formed the tail towards the right. See, towards the right, mostly data form the tail from the median. Okay, mostly data form the tail towards the right. Okay, so this is what intuition we get from this stuff. Okay, second, if you look at the there is a one more point. If you look at the income, okay, income mentioned as a 2, 4, 6, 8, 10. So income never be 2, 4, 6. They do the pre-processing on the income. So what it means that when I mention the 2, let me take it to the data frame here. Yeah, income here. See, no, not this. Here, yeah, income. So when I say income is 8, 8 is nothing but the $8,000. 8.3 means 8,000. 7.2 means $7,000. So they actually scale it down to the one number. Okay, but guys, it is very important when we are considering the income with the any other stuff. So we have to standardize. For example, for the housing value, okay, for the housing value, the house value we consider only till 50,000. Okay, this is a 1, 2, 3, 4. Yeah, it's a 1 lakh, 2 lakh, 3 lakh, 4 lakh. So for the value, we are considering the actual value, but for the income, we are considering only the pre-processed stuff. So it is very important to do the standardization. Now, what is the standardization? Standardization is nothing but it is a part of feature scaling where we scale down all the feature in one unit. Okay, otherwise what happened, my machine learning algorithms learn something wrong and gives the more importance to the larger value and do the wrong stuff. So we have to do the standardization so it will relate to each other stuff, because for the income we consider 2, 4, 6, and for the same dollar price we consider in the actual. Again, one more important stuff, guys, it gets that only till 50,000 the maximum value it is. So we need to consult with the client, is it really or not? Okay, is it something that our housing price value is only till 50,000 or more than that? We must have to ask this question. Okay, if it is not, then we have to also handle this case. Otherwise what happened, my machine learning problem only predict the value till 50,000 only, and it will not predict the value above 50,000. So we have to also handle that case, that is that the housing price will never go beyond 50,000. So that stuff we also have to consider. Okay, now there are the way to handle this stuff, but we will see it later how to handle this stuff. Okay, now guys, I think till now we have covered a lot of stuff, how to get the data, but again in next session we will do the visualization. There I will explain in much more detail. Okay, now the most important stuff is to split the data. Okay, to split the data. So to split the data we will use the sklearn, because as I mentioned in my previous lecture, it is very important to split the stuff. Okay, so we will split the data into the train and test. Okay, now to split the data, okay, we will use sklearn library called as model selection, and here we will mention the test size into the 0.2 and random state as 42. Okay, so what it will does, it will split my data into the train and test, where it will consider my test size is 20% and my train size is 80%. So to mention the 20%, I'll mention 0.2. Okay, now let's let's execute this. Yeah, and let's look at the length. Yeah, it's 1640, and my test set contains the yeah 6214. If I do the addition, I'll get the total value. It's plus, just to verify. Yeah, it's 2640. So this way you are doing the splitting of the data into the train and test. Okay, because it is very important. You have to do the splitting before only. If you do the splitting after doing some pre-processing or after doing some feature engineering, then what will happen? It will give the rise to the overfitting issue. So it is always recommended, do the splitting before doing any feature engineering or feature scaling stuff. So it will avoid my algorithms to see the data. Okay, and we will in the position to develop the model in a generalized way. So guys, till today, this much I think we have got a lot of stuff. We have, just to summarize, we get the data from GitHub, we understand what are the information contains in my data, then we try to understand each and every step, what is standard deviation, mean, max, and count, and then we also draw the histogram and try to analyze the data. Then after that, we divide the data into the train and test split. I hope so you understand what I have explained. Okay, please keep watching and don't forget to like, share, and subscribe. Till that time, all the best. Thank you.